If someone told you there's a region where about 90% of the earthquakes that shake our planet occur, and what if they told you that this region also hosts over 75% of the world's active and dormant volcanoes, and that all of the 25 largest eruptions in the world in the last 11,700 years, except for 3, have taken place here? You'd probably think twice before buying a house in that area, wouldn't you? But strangely enough, hundreds of millions of people live in that area, and some of the most densely populated cities in the world have been built right on those shaky fault lines. Yes, we're talking about the Pacific Ring of Fire, a geologically and volcanically active region that stretches from one side of the vast ocean separating the Americas from Asia and Australia to the other. The Pacific Ocean, as we all know, is the largest body of water in the world, covering over 60 million square miles. It constitutes about 28% of Earth's total surface area and represents 46% of the total water surface. So vast that it could comfortably contain all the land masses. Well, it certainly won't happen in a year or a century, but the day will come when this immense body of water will shrink until it disappears, enclosed in the increasingly tight grip of this deadly ring. Planetary forces, frighteningly slow, which almost seem distant and absolutely harmless when judged from our human perspective, but which can suddenly involve us in situations of destruction and death. Let's discover the meaning of all this in this splendid video, as usual, curated and produced by the Insane Curiosity channel. Geologists often speak of the Earth as a dynamic planet, a world that constantly is in a state of dramatic change. Across much of the Earth, however, it is difficult to see direct evidence of these rapid changes because most geological processes are achingly slow. Even in the best of circumstances, it takes hundreds to thousands of years for sediment to be buried and turned into rock. Rocks are weathered into sand, but the weathering processes can take thousands or even millions of years. Mountains can rise from the plains, but this often takes tens of millions of years. Why then is Earth considered such a dynamic planet? The answer lies in the relentless movement of the Earth's tectonic plates. The Earth's plates are in constant motion because of the circulation of the upper mantle beneath them. At places where plates come into contact with each other, the Earth changes rapidly and dramatically. It is at these places that earthquakes disrupt people's daily lives. It is at these places that volcanoes destroy landscapes, only to rebuild them in a new image. It is along shorelines with such plate contact that tsunamis can sweep in and carry away communities in a tragic few minutes. In very few places are these types of events seen more frequently than in the region called the Ring of Fire. The Ring of Fire is a name given most deservedly to the Pacific Rim, a major area in the basin of the Pacific Ocean where a large number of earthquakes and volcanic eruptions occur. The ring is sometimes called the Circum-Pacific Belt. In a horseshoe shape spanning 40,000 kilometers or 25,000 miles, it is associated with a nearly continuous series of oceanic trenches, volcanic arcs, and volcanic belts, as well as plate movements. The sliding of tectonic plates in some areas around the Ring of Fire has also led to the formation of deep underwater trenches such as the Mariana Trench, the deepest point in the world. But how many countries are involved in this giant puzzle? The number of countries along the Ring of Fire varies depending on how strictly you define the region. Estimates range from 15 to 22 countries. Here are some of the most commonly included countries: North America, United States, Canada; Central America, Mexico, Guatemala, Costa Rica, Panama, Nicaragua; South America, Chile, Peru, Ecuador, Colombia; Asia, Russia, Kamchatka Peninsula, Japan, Philippines; Oceania, Indonesia, Papua New Guinea, New Zealand. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. While geologists and oceanographers largely agree on most regions included in the Ring of Fire, some areas are controversial and remain subject to debate. The region encompasses much of the Pacific coast of North America, South America, the Kamchatka Peninsula, and some islands in the Western Pacific. However, there is no consensus on the inclusion of western Indonesia and the Antarctic Peninsula. Indonesia's position within the Ring of Fire is contentious because it lies partly within both the ring and the Alpine Belt, a region with frequent volcanic eruptions and earthquakes. Therefore, some geologists consider the entire Indonesia as part of the Ring of Fire, while others include only the western part. The next question might be, when did we become aware of this ring that is suffocating the Pacific? Well, the concept of the Ring of Fire is not a recent formulation. The ring has been identified retrospectively over time, starting from the detection and mapping of major earthquakes that have occurred worldwide in recent times, and the recognition of all major volcanoes on our planet. The development of plate tectonics theory since the early 1960s has provided the current understanding and explanation of the global distribution of volcanoes and earthquakes, including those in the Ring of Fire. However, the existence of a volcanic belt encircling the entire Pacific Ocean was already known in the early 19th century. For example, as early as 1825, the pioneering English volcanologist George Scrope noticed the unusual volcanic activity along the ocean's edge, and an article published in Scientific American in 1878 titled "The Ring of Fire and the Volcanic Peaks of the Western United States" already outlined the nature of the phenomena with sufficient precision. Those were the years when all one could do was accumulate facts, numbers, and suppositions, without being able to arrive at an answer regarding the causes of such a geological alignment. It was only in the 1960s that the frequent earthquakes and the presence of numerous volcanoes along the Ring of Fire began to be understood as the result of the tectonic movement of plates, which, like puzzle pieces, continue to vie for space floating on the lithosphere. A titanic and endless struggle, capable of redesigning the appearance and position of the land masses over hundreds of millions of years. A struggle far from painless. These plates, in fact, end up colliding with each other along the so-called subduction zones, where the heavier plate usually loses out and is forced to sink beneath the less dense one. The eastern parts of the belt, those outlined by the coastlines of North and South America, are formed by the collision of very extensive continental-type tectonic plates, while the western parts result from the collision of more fragmented plates, giving rise to more complex geology. For much of its length, especially on the Asian side, the Ring of Fire follows chains of archipelagos such as the New Hebrides, Tonga, Japan, Philippines, Kuril Islands, Solomon Islands, and Fiji. But exactly what are the plates that form the ring? The tectonics of the Ring of Fire exhibit a complex interplay between several major and minor plates. Here's a breakdown of the key players. Pacific Plate. The dominant force, the vast Pacific Plate forms the core of the Ring of Fire. Its interactions with surrounding plates create most of the geological drama in the region. Eurasian Plate. Bordering the western Pacific, the Eurasian Plate converges with the Pacific Plate, forming subduction zones and island arcs like the Japanese islands. Indo-Australian Plate. Located to the northwest of the Pacific Plate, the Indo-Australian Plate interacts along complex boundaries, including subduction zones like the Mariana Trench and Transform Faults. Smaller plates. The Ring of Fire also features several smaller crucial plates. These include Juan de Fuca Plate, subducting beneath the North American Plate, responsible for the Cascadian subduction zone and volcanic activity in the Pacific Northwest. Explorer Gorda Plates. Off the coast of North America, these plates subduct under the North American. Philippine Plate. Subducting westward beneath the Eurasian and Philippine Sea plates, creating island arcs and trenches. Cocos Plate. Subducting beneath the North American and the Caribbean plates, responsible for volcanic activity in Central America. Nazca Plate. Subducting beneath the South American Plate, forming the Andes Mountains and causing earthquakes in South America. The dynamic interplay of these plates through subduction, convergence, and transform fault movements shapes the Ring of Fire's intense geological activity. The Pacific Ocean is narrowing due to the movement of the continental plates that surround it, namely those upon which currently emerge America and Asia. In other words, the Pacific Plate is sinking beneath the surrounding plates in a continuous process of collision. Along fault lines, there is a significant upwelling of magma from underground, and the accumulated lava can gradually give rise to islands, island arcs, archipelagos and large mountain ranges, such as Japan itself, or, for example, the South American Andes. Of course, we're talking about processes that take millions of years to fully develop. Friction between the plates is thus the driving force behind everything, and the resulting volcanism is just a sign of the colossal heat development at play. Receiving its fiery name after the half a thousand dormant and active volcanoes that lie within it, the Ring of Fire includes 75% of the world's active volcanoes and is also responsible for 90% of the world's earthquakes. All but 3 of the world's 25 largest volcanic eruptions of the last 11,700 years occurred at volcanoes in the Ring of Fire. But the exact number of volcanoes in the Ring of Fire depends on how you define the region's boundaries. Estimates range from 750 to 915, with around 2/3 of the world's active or dormant volcanoes found there. That's a whopping 452 to 540 volcanoes, most of which are located in the Asian continent. 109 in Russian territory, 81 in Japan, and 70 in western Indonesia. More than 150 are found in South America, with Chile accounting for 71, Ecuador for 21, and another 18 located on the border between Chile and Argentina. In North America, there are approximately 209 volcanoes in the ring, with over half of them in the United States. Here are a few names, sure to bring back memories of distant natural disasters. The Andes, running 5,500 miles or 8,900 kilometers north and south along the western edge of South America. The Andes Mountains are the longest continental mountain range in the world. The Andean volcanic belt is within the mountain range and is broken up into 4 volcanic zones that include such active volcanoes as Cotopaxi and Cerro Azul. It is also home to the highest active volcano, Ojos del Salado, 687 meters or 22,730 feet. Popocatépetl. Popocatépetl is an active volcano in the Trans-Mexican volcano belt. Located near Mexico City, this volcano is considered by many to be the most dangerous in the world, since a large eruption could potentially kill millions of people. Mount Saint Helens. The Cascade Mountains in the United States Pacific Northwest host the 800-mile, 1,300-kilometer Cascade Volcanic Arc. The Cascades contain 13 major volcanoes and nearly 3,000 other volcanic features. The most recent eruption in the Cascades occurred at Mount Saint Helens in 1980. Aleutian Islands. Alaska's Aleutian Islands, which consists of 14 large and 55 small islands, were made from volcanic activity. The Aleutians contain 52 volcanoes, with a few of the most active being Cleveland, Akmok, and Akutan. The deep Aleutian Trench, which also sits next to the islands, has been created at the subduction zone with a maximum depth of 25,194 feet or 7,679 meters. Mount Fuji. Located on the Japanese island of Honshu, Mount Fuji at 12,380 feet, 3,776 meters, is the tallest mountain in Japan and the world's most visited mountain. However, Mount Fuji is more than a mountain. It is an active volcano that last erupted in 1707. Krakatoa. In the Indonesian island arc sits Krakatoa, remembered for its massive eruption on August 27, 1883, that killed 36,000 people and was heard 2,800 miles away. It is considered the loudest sound in modern history. The Indonesian island arc is also home to Mount Tambora, whose eruption on April 10, 1815 was the largest in major history. Mount Ruapehu, rising to 9,177 feet or 2,797 meters. Mount Ruapehu is the tallest mountain on the North Island of New Zealand. Located in the southern section of the Taupo volcanic zone, Mount Ruapehu is New Zealand's most active volcano. Well, there's no denying that our planet is often referred to as a natural paradise, and rightfully so, because the life forms, landscapes, and great environmental variety make it a spectacular adventure to experience day by day. But at the same time, sometimes it's important to reflect on the fact that we live on a subterranean world ready to suddenly transform into a veritable hell. However, who knows? Perhaps the true beauty lies precisely in this contrast. What do you think?